Hello learners, greetings to you all. This is teacher Baidu Simon, a teacher of biology and chemistry. Today in this session we shall be in chemistry. I would like to welcome you all in this session, and we are going to continue with using materials. In our previous session, we looked at the categories of materials, and even we looked at what materials are. We got to know what materials are and even the categories of materials that we have. Then even we looked at the different materials that are in different categories. In that session, we said that materials, these are substances from which our objects, the daily objects we use in our daily life, are made from. And we said we have two categories of materials. That's natural materials, which are got from the environment with less alteration by man. Then we have the artificial materials that are manufactured, or the synthetic materials which are manufactured by man. These ones, they are got from the natural environment, but they involve much alteration before they are made. And now, in this session, I want us to look at the properties of materials. Those will be the physical and chemical properties of materials. Then we shall look at identifying materials. We shall identify metals and even the non-metals. Then we shall have to identify materials in common objects. We shall get to know from which materials are some of the common objects that we always encounter in our daily life made from. And here we go. The physical properties of materials, then the chemical properties of materials. These properties determine how we use these materials. These properties tell us which material is best for this and which material is best for the other. And we shall start with the physical properties. And here they are. We are going to concentrate ourselves on 4 physical properties of materials, and these are transparency, strength, conductivity, and flexibility. Assuming we have objects in our life, look at the glasses in the windows. That's one. Look at the wood, or look at this metal rule. It's a wooden one. It's there. Look at the wires that conduct electricity. Or look at iron, and look at a nail. Iron nail, a nail. Then we can have even a plastic cup. Those are our materials, or our objects, sorry. Those are our objects we are going to consider in this session. Now, let us start one by one. Transparency. When you look at a metal rule, if you use a torch and you illuminate this side, you point the torch here, are you able to see the light from the torch? If I point a torch here and I keep my eye closed like this, can I see that light? If it's in glass, can I see the light? If it's in a plastic cup, can I see? Or if it's in iron nail, can I see light at light? If you cannot see light, then it means that material is not transparent. And if you can see light, it means that material is transparent. And if your glass is transparent, that's why you are able to see light when you look through windows which have glasses. Strength. In strength, we are looking, can it be able to hold a weight without breaking? Assuming we use this meter rule and we suspend it here, then we place a weight at this level or at this point. A weight, let me say 1 kilogram mass downwards. Can this meter rule hold this 1 kilogram mass without it breaking? That is the strength. You look at this, let us look at the strength of glass. If you have a glass block and you place on it a heavy weight, for example 5 kilograms, can it hold it without breaking? Look at iron nail. What happens if you place an iron nail somewhere, then you attach on it a heavy weight? Can it hold it without breaking? The same story to a plastic cup. If you suspend a weight, so we are looking, is it strong to hold a weight? You find that some materials are strong. For example, the iron nail, you find that this rule, because it is wooden, it can hold some weight, but if the weight goes beyond, it cannot. You find that the plastic cup, to a small extent, it can hold some weight. Likewise, the glass. But the strongest among all is the iron nail, followed by the plastic, followed by the meter rule, then the plastic cup, and glass comes last. Meaning, glass is not strong. Then you go to conductivity. When you talk of conductivity, we are meaning if we use that material and we connect it to wires that are connecting, or we apply it in a circuit, does it complete the circuit and our bulb lights? For example, if we use a glass rod and we connect, we include it in our circuit, does the bulb produce light? Or if we use this wooden meter rule and we add it in our circuit, connect wires this way, does the bulb produce light? Or if we use a plastic cup, we connect wires on it, does the bulb produce light? Or if we use glass or iron nail, you find that when you use glass, this meter rule, the wooden one, and the plastic cup, the bulb may not give light. But when you use the iron nail, it can give light. Meaning, these ones do not conduct electricity, but this one conducts. Then we look at also heat. If we place heat there and we connect this meter rule to heat, to the heat source or fire source, can we really feel the heat this end, provided the fireplace is this end? You try the same story to glass rod, you try the same story to plastic, and even to the iron nail. You find that some materials, you feel the heat from the fireplace, and others you cannot feel it. Meaning, those ones they don't conduct heat, and the others are conducting heat. Then flexibility. Can we bend it? Can it be bent easily without breaking? Can you bend glass? When you look at this meter rule, I can bend it somehow, but can you bend glass? Can you bend an iron nail without it breaking? Can you bend a cup, a plastic one, without bending? So that's the flexible. Is the material flexible? Those are properties. Some materials are transparent, some materials are strong, some materials conduct heat and electricity, some materials are flexible. Those are the physical properties of materials. When we say physical, we mean what we see. what we see, you'll see it bending, you see it breaking if you're trying to bend it. Those are the physical properties. Now let's go to the chemical properties of materials. And here we have flammability and reactivity. And when you say reactivity, we are meaning water and acids. Chemical properties. This is how these materials react or behave when they come into contact with something else. How do they behave? Those are the chemical properties. Flammability, we are meaning, can it burn into flames if we connect it to fire or a flame? Look at the materials we have been looking at. That is a glass rod, this wooden metal roll, plastic cup, and the iron nail. If you connect these ones, all of them, one at a time, to a fireplace, which one burns and which one does not burn? You find that wood will burn. You find that the plastic cup will burn. The iron nail will not burn, and even glass will not burn. Meaning, those ones which do not burn are non-flammable, and those ones which burn are flammable. Then, reactivity. When we talk about reactivity, we are looking at how it will behave when it comes into contact with water, and how it will behave when it comes into contact with acids. We can experiment this. We get a given volume of an acid in a beaker, then we dip small portions of wood, we place their glass, one at a time, then an iron nail, then even a plastic cup. We see all a plastic part or a plastic material, any plastic material. We can get a plastic portion of any plastic material and drop in there. You find that with wood, you may not see some much change. With glass, you may not see anything. With a plastic cup, you may not see anything. But when it happens to come to an iron nail, you can see bubbles of gas being given off, or what we call effervescence. Meaning, the iron nail, the material from which it is made, is reactive when it comes to acids. And the same story with the water. You find that the rest of the other materials may not give anything observable with the water. But iron nail, if you dip it in water and leave it for some time, you find that it will turn color. It will turn from its shiny color and it rusts, becomes yellow-brown or brownish, the color of rust. So these are the properties of materials. These properties determine what we use these materials for. Identifying materials. And here we're going to identify metals and non-metals. How can we know that this material is metal and this one is non-metal? We shall have three properties we shall consider, or physical properties. We shall look at shiny, we shall look at durability, and we shall look at conductivity. We shall have to identify different materials to see whether it is shiny, whether it is malleable, or it conducts heat or electricity. We are starting with metals. Now, let us have some materials. We can use the same materials we had. For example, this metal roll, glass, plastic cup, and even iron nail. We start with the first one, shiny. we look at the glass. We look at the metal, a wooden one. Is it shiny? You look at a plastic cup. Is it shiny? Or you look at the iron nail. Even if it is rust, or it has rusted, you can use a sandpaper and you pass it around. You will see the shiny part, or the shiny iron, the shiny metal within inside the rust. When you pass sandpaper around it and you remove the rust, you see the shiny of iron nail. Glass appears to be shiny sometimes, and sometimes even plastic. But the way iron nail shines is more than the way glass, plastic cup, or even wood. Malleability. When we talk malleability, when we say malleability, we are meaning, can we bend it? Can we turn it into another shape without breaking? For example, we have the same materials. If you turn this one, if I say this is now straight, can I make something which is L-shaped? I turn this part, I make it like this, and it looks like an L. It appears to be hard. If you get a plastic cup, can you make it to be like a plain, something which is plain, which is not like in the shape of a cup without it breaking? Look at the iron nail. Can you bend it and you form something let me say which is circular, a circular shape without it breaking? And the same story, when you look at glass, can you bend glass without it breaking? That brings us to malleability. You find that metals are malleable. You can bend an iron nail into circular form, but the rest of the other materials, you cannot. Conductivity. Conductivity, we are looking at heat and electricity. And we have discussed this, we have looked at this when we're looking at properties. You find that metals conduct electricity. When you connect them into circuit, a bulb can give light. Unlike the nanometals like wood, glass, plastics. So that is how we can identify that this one is a metal. If it is shiny, or we can say luster. If it is malleable, or if it conducts heat and electricity, or any of the two. Now, you find that being shiny, metals are used to make a jewelry, and being malleable, they are used in making jewelry. Metals are used in electric wires because they connect electricity, and they are malleable. Wires bend. They are bent in rooms, in buildings. So this one makes them to be good. Metals are used in making frying pans, saucepans, because they connect heat. The other metals. For other metals, and for example of the metals we can give, we can talk of iron, copper, aluminium, we find that aluminium can be used in making saucepans, aluminium foils, which can be bent without breaking. Copper is used in wires. Iron is used in making iron nails, iron sheets, and many others because of its properties. Then the nanometals. We shall use the same to identify the nanometals. So the opposite, if it is the opposite of this, then it becomes a nanometer. For example, I can talk of carbon. For example, chalk. If you get chalk, is it shiny? Is it malleable? You can bend it into another shape without it breaking. Can it conduct if you connect it to a circuit? Can the bulb give light? Or if you connect it to a heat source, can you feel the heat? If it is wood, what does it give us? Does it have any of these ones? Then if it is the opposite of this, then it becomes a non-metal. That is how we can identify metals and non-metals. We base on these ones. Identifying materials in common objects. And this is our last part of this session. We have these ones. Flying bar is common. Have electric wires, then the doors and the windows. Today, in this session, you are like engineers. If we want to manufacture or make a flying pan, which materials are we supposed to use? Because when we look at a flying pan, we need something which heats up fast, but again it must have a handle which doesn't burn. That's a good frying pan. So we need something which conducts heat, and now they will go for a metal. And we need another metal on it which does not conduct heat, so it does not burn us. We can either use plastic or wood. So we call it fitness for purpose. We choose a material because of its best property. We choose a material because of its properties for the task we are going to do. The material we have to choose, we base on its properties for the task it is going to do. Look at electric wires. Of course, we need something which completes a circuit. But when it is malleable, because wires bend, you cannot have wires which are constantly straight, so it has to be malleable. But when it completes the circuit, that's how we can go for metals. The doors and windows. What happens? Windows have to be transparent. That's one. But are they supposed to be so fragile, so weak that anything can pass through? Because we have to think of being burglar proof. Thieves come and steal property. So windows need strong materials, but again they have to be transparent. That's how we bring the idea of using the metals to make the frame and even the burglar proof. And then we put glass so that we can see through. Fitness for purpose. The doors can lead them to windows. We can choose to make a door which is not transparent, because we can see through the window. We can choose to make a door which is transparent. It depends on the need of the engineer. And that's one, fitness for purpose. What did you need? Then we choose the material. And that has marked the end of this session. But before we come to the end of the session, we need to look at the signs, safety signs that indicate, because materials we use, some materials are flammable, others are what we call corrosive when they affect tissue, like the skin. Others are toxic, they can kill us. When you deal with them, they can kill you and you die. Let us look at the safety signs. But where you can look at and understand that this material is flammable, this material is toxic, this material is corrosive. Here are our safety signs. This one means toxic, it can kill, it is poison. This one is corrosive, meaning if it happens to come into contact with tissue, also like the skin, it damages it. This one is flammable, meaning the moment it comes into contact with fire, it burns into flame. So whenever you are going to use a material, whenever you are going to use a product, whenever you are going to use an object, look at the safety signs which can be indicated on it, so that you use when you know how the material reacts with other substances it comes into contact with. Because you might connect a flammable object or an object that was made from a flammable material and it burns. You can come into contact with corrosive objects whose materials are corrosive. You are affected. The same story to toxic. We need to ensure safety first.